Welcome to ARM video number 5, from C to assembly, or I hate assembly, because I do. Imagine that you're writing a piece of code and you need something like an if then else. So you go and you write your if then else in C, and then the goal is to convert this if then else code into assembly language, because it's what you have to do in this case. So how to do that? One way we can go about it is first we write our code in C and then we make the conversion. If we do this often, we will end up with a bunch of templates that speeds up development quite a bit. Let me teach you this strategy. First of all, we need to understand how this if then else will translate into assembly. Let's look at the structure. The first thing to notice is that we have a logic expression. This is our logic expression. And what happens is that if the logic expression is true, we're going to continue executing sequentially. We're going to run the then block of code. If the logic expression is false, then we are going to branch to the else code. There is a problem. If the then code completes execution because it's sequential, then you are going to start executing the else code too. And in the end, if we don't do anything, we're going to end up executing the then and else code all together when we have the logic statement evaluated to true. How we fix that? Once we reach the end of the then code, we branch to the end of the if statement. We don't have to do that for the else, because when the else code finishes, we are already at the end of the if statement and we can keep running. So let's go and write this part first. So we have for the if statement the initialization. This is really not very interesting for this example, but basically you would put on the if init is the loading of any registers that require to be set up before we can test the logic expression. So in this case, I'm just going to assume that X is in R0 and that Y is in R1. Now we need another label, if logic, for the logic statement. If then, if else, if n. So I want to put placeholders for the if then and if else blocks of code. There is a very interesting instruction, is the NOP instruction. So NOP, just do nothing. So I have a NOP as a placeholder for the if then and NOP as a placeholder for the else code. And I'm going to put a NOP to signal the end of the if then else statement. Remember that when we finish with the then code, we need to have a branch, unconditional branch, to the if end. So let's put that one here, b if end. What remains is the if logic. The if logic is the most challenging part of implementing or translating an if then else from C to assembly. In this case, we need to think what is being asked and what we want to do. Well, we already have the structure. We have the if then after the if logic. So we're forced in this case to write a logic statement that will allow us to branch to the if else. So let's do that. That's one way to do it. We know that if X is equal to Y, then Y minus X is equal to 0, and we know that if we use the sub instruction, it will modify the flags. The C flag will take the value 1. We also know that if Y is greater than X, then Y minus X is going to give us a positive result. We'll have positive sign. And notice I'm changing the way this statement is controlled. Why? Well, if this is true, I want to keep going. And if this is not true, I want to branch. but the branch is what determines how this thing is going to work. So I just flip the inequality to match one of these branching conditions. And after looking at the different branching conditions we could put next to a branch instruction, I found that hi, or unsigned higher, is a condition that will make the branch if the result is unsigned higher. So that is, if y is greater than x, and I can check that by performing a subtraction, then I'm going to branch somewhere else in the code. If y minus x produces 0, the branch is not going to happen with this condition. So let's write that code. Sub s to modify the flags, and I want to subtract r0 from r1 and put the result somewhere else. Let's say that I cannot modify r1. It has to be saved into another register. Let's choose r2, assuming it's free. So r2, comma, r1, comma, r0. And then let's use bhi if else. And we're done. Is this the only way to do this? No. In the next example, I'm going to show you how to do it differently.